Hi guys, welcome to a quick video on Vernier probes and analysis software, but also the lab that you guys are working on currently for the characteristics of water. Now, if you're working in Loggerlight, which is one of the possible Vernier software programs, you're always going to want to go into experiment, data collection, and you're always going to want to make sure that you have the correct duration. You can choose seconds or minutes or hours. And I always like to think about how many seconds is it going to take one sample. So if I'm taking a sample every 10 seconds, I'm really sampling zero point 0.1 samples every second. 10 times 61 is going to give me about 600 seconds worth of data. If I'm using the Vernier graphical analysis, I can also do that by clicking this time-based mode. And this is also going to allow me to manually enter the duration, the rate, or the number of seconds per sample. I also can change units over here between different things. We're usually going to use Celsius when it comes to temperature. Now for your lab, where you're going to be answering some questions related to your understanding of water versus lipids versus ethyl alcohol, your first question is going to be looking at creating a line graph with temperature in Celsius as your x-axis, or your y-axis, I'm sorry. And your x-axis is time in seconds or minutes, and right around here at the 5-minute mark we should see inflection points. The three other questions you're going to be working on have to do with percent differences between density in solvents, evaporative cooling, and also surface temperature. And you're going to be doing a calculation called percent difference for a lot of that analysis, and I have the equation below each table. To give you an example, I might want to know the difference between water and oil when it comes to each of those liquids evaporative cooling. So if I had water as dry at 25 and wet as 21, I have a 4-degree difference, but oil was only 25 to 24 with a 1-degree temperature difference. So let's take a look at this equation. The percent difference between two values is going to be the difference of those two values divided by their average times 100. So 4 minus 1 divided by 0.5 of 4 plus 1 times 100. That gives me 4 minus 1, which is 3, divided by 2.5, which is 0.5 times 5, times 100, and I get 120% as the percent difference. Now you're going to be answering a couple series of questions, and I want you to practice citing data in each of these responses, and also citing tables and figures within your data. And I have some examples right there. The first series of questions has to do with blood, which is about 55% water by volume. And you're going to be thinking about water being within blood as it pertains to the ability to move heat, move molecules, and also cool our bodies. And that's going to lead you to justifying why water might have utilized or evolved to utilize water as a mechanism for transport. The second question is going to be having you taking a look at Boston, Massachusetts average temperature profile. January through December, the average low and the average high daily temperature. And you're going to be thinking about how water really impacts the environmental parameters of an ecosystem. Boston, Massachusetts, if you didn't know, is right next to the ocean. And then finally, you're going to be thinking about our body's ability to sweat and why sweat is so important for our ability to cool. Each of these does not require a lot of writing, but I really want you to practice being concise, answering the question as specifically as possible, and also citing your evidence. I hope this has helped, and again, if you have questions, feel free to reach out and ask me for any support or advice. Have a great day.